Today I want to talk about GraphQL and why I think it's really important that we have a technology that is just like GraphQL. And I have like a small problem, which is that I prepared a talk for 30 minutes, and then this morning I looked at the schedule and I was like, oh, I only have 10 minutes. But I think I can do it, but I'm going to need your help. So just want you to all be on the edge of your seats and kind of work with me. So first off, who has heard of GraphQL? All right, that's probably 2/3. Who has tried it? All right, 10% maybe? Who's using it at work? All right, I see one person. That's Lauren. Lauren's my friend. Where? Thanks, Lauren. All right, so I kind of want to make the case for GraphQL here by trying to build an app and seeing what we would need to do to build this. So let's say we wanted to build a blog platform that's kind of like Medium. And we're just going to look at one view, but keep in mind that we'd have many views probably. So in this one view, what we want to show is we want to show the title of a bunch of blog posts, the most recent ones maybe. We want to show the author. We want to show like how many recommends it has and things like that. So we kind of have a model. So if you were doing SQL, you'd like write a SQL schema. We have a user who has a name. The user's written some posts. Posts have titles. They have authors. They've been recommended by someone. And then there's comments. Comments are like text, and they're associated to a user. So how would we go about building this? If it was like 2010, we would probably, we'd use Linux, MySQL, Apache, and PHP, or yeah, in whatever order. And so we'd have one monolithic web server. It would have a SQL database. We write the schema. That web server serves static pages over HTML, and there's like browsers that consume it. So far, so good. So that would be pretty simple. But it's not 2005 anymore, so things are a little different today. And let's say we're building something, and we're building something that's supposed to scale because someone told us it has to scale, and I want to use like microservices because that's what I heard how you have to do it. Just to be clear, that's not how I would build a V1, but that's what you're eventually going to end up with. So you're going to have a microservice architecture where on the servers, you might have a user service that's powered by SQL, but your posts might be in a different database, or they might, in order to make them searchable, you might be using some external service for giving your users recommendations and things. On the client side, you don't just have browsers. You now have you have browsers, but you also have native apps. Maybe you have some Cordova, and in the future, who knows, maybe you have some Amazon Echo apps and things like that. So it's really getting a lot more complicated. So what's kind of the common pattern then of like building out these kinds of APIs? So there's kind of two approaches that people do, but in reality, there's only like really one that's left. So kind of the pure REST approach would be to build one REST endpoint for each type of resource. So if you have an endpoint for users, so you can ask that for like, I don't know, API/user/1. That gives you user 1 and all the information you want to know about that user. And that'll have like some links in it, some URIs for posts, for example, that would refer to that user's posts. And then there's another endpoint that would have the comments in there, and the clients can piece together whatever they need. And this is great because it's really flexible and it's decoupled. So if you want to build something slightly different on the client, you don't need to change the server. You can just change your client. But the disadvantage is that the client's actually doing lots of round trips, because first it has to load kind of the list of recent posts, and maybe that only returns a list of IDs or a list of references. And then it has to go and fetch those posts, and then it wants to know the name of the author of that post, so it has to go and hit the user's endpoint. So you're really doing lots of round trips. And each of these endpoints is probably built in such a way that if it's pure, it'll return the whole object. So you're actually fetching way too much content, because you probably only care about the name of the author. You don't care about like how many followers he has, when he joined the service, and things like that. This also makes the clients kind of complex. So what's the other approach? And yeah, just say like I think the biggest disadvantage here for many people is the fact that this takes lots of round trips, which is especially troubling on mobile when you can have high latency. So you'd have an app that like takes 5 seconds to load, or maybe even more. So what people usually end up doing is they actually build these custom REST endpoints for each view. So remember we had like this recent posts view, and what we wanted was the titles of recent posts, and we wanted the names of the authors and how many people recommended it. So, you know, let's call that view A. So we'd have an endpoint for view A. And if there was another post that was basically showing the details, or another view that was showing the details, we'd build a separate endpoint for this. And if we have a mobile client that's showing like slightly different data, we'd build yet another endpoint. And what's great about this is it's super fast, because you know, you only do one round trip and you have exactly the data you need for that view. The disadvantage of that is that it's really inflexible. Like you have a super high maintenance cost, because every time you want to change a view on the client, you have to change something on the server, right? So you're spending a lot of time to develop, and it's really slow to iterate, and like the backend people or the front end people keep bugging you. It's like, oh, I need this data in this view here. Can you add this to the endpoint? And you're like, ah. So you kind of feel like this in the end, because you're trying to get all the data into the right place in the app, and it's like so complicated, and you know, a little change in the server, and suddenly some client breaks. That's not great. So what we really want is a standardized API layer, kind of a unified layer on top of all these databases, or on top of all these microservices, that lets us kind of select exactly the data we want and join across those services. So you shouldn't have to care if something's stored in, you know, MongoDB, or if something's stored in SQL, or if there's another external REST API that you're using. For the clients, it should all look the same. So we want like this kind of abstraction. We want to be able to do just one round trip, get exactly what we need, and we want it to be flexible and decoupled. And that's kind of exactly what GraphQL provides. So with GraphQL, you can ask for exactly the data you want in one round trip. You get just what you asked for, and you have a backend that's completely decoupled from the front end. So it's a clean abstraction. When you change things on the front end, you don't need changes on the back end. When you change things on the back end, as long as the API layer stays the same, you don't have to change the clients, and you won't break them. So here's a simple example of a GraphQL query that will get us all the data that we want for that view to show the recent posts. So we ask for a title, a slug, like the total count of recommends, and we want to have the author, the name of the author. And this could be, you know, fetching from many different services on the back end, but on the front end, you kind of don't see that. So I have a super short demo that I'm going to try to do. Let's see. All right, I'm going to try to make this larger. Can people kind of see it? Probably too small, right? How's this? So we have the query on the left, and we execute that query. And on the right side, it gives us exactly the data we want. Now let's say we also wanted to know how many followers this author has. We simply add the followers, and we ask for the total count. And boom, there it is. Let's say, oh, we don't actually care about the number of recommends, so we don't want to fetch too much data. We just take it away, we run again, and boom, we have exactly the data that we want. All right, that was my super short demo. So GraphQL really provides you with 3 core things. It gives you an API definition language to describe the types and their relationships. So that was the schema, kind of the schema that I showed you at the beginning. So you kind of write something like that out for GraphQL. Then it gives you a query language to specify exactly what data you need. And it kind of gives you an execution model that you don't have to follow, but it's like a nice execution model that allows you to resolve single fields. And it's that resolving single fields which lets you do joins across different databases, because you just define in a small snippet of code in the thin API layer how to fetch a certain field. And that field in the schema can have dependencies to other parts, to other backends. What's important to know about GraphQL is that it's a specification and not an implementation, and that has some like huge advantages. It means that there can be implementations in pretty much any language. So there's a bunch of servers. You can have servers for Node.js, Ruby, Python, Scala, Java, Erlang, Go. There's clients. You can just use curl if you want, because you can just treat it as a string. There's also caching clients built for React, like Apollo clients, the one that I'm working on, and Relay built by Facebook. And then there's integrations for Angular, Vue, Polymer, and so on and so forth. And you get really cool tools. Because it's not an implementation, but a standard, people can build tools against that standard, and then everyone can share those tools and use them. So the thing that I just showed you, where I demoed this query, that thing's called GraphQL, and it has a lot of really cool features. So if you have time, you should check it out. So last slide, kind of, if you haven't heard of GraphQL yet, and you're wondering, like, who is really using GraphQL? So here are a bunch of logos of companies and small and big companies that are using GraphQL in production already or have started working on putting GraphQL into production. And so this was a pretty short presentation. You probably have lots of questions, but since it's a lightning talk, I don't really have time to answer questions, which means you should definitely stick around for Lauren's presentation this afternoon. I think it's called All the Databases, where he'll basically be showing what GraphQL looks like on the server and how to write the code that actually puts these things together. So I highly recommend listening to his presentation. All right.